Okay, question number 3. We have this rule, so let's type that in over here. 2. Okay, so we've drawn that. It represents the height on a high tide marker at the base of a boat ramp. Okay, so it's the height of the tide. And here is the marker here. Okay. T equals 6, we have 6 o'clock on Monday morning. So T equals 0 is midnight on Monday morning. Okay. And we've been given a graph. Okay, so find the water height on Monday morning. So let's say we define this. So at 6 a.m., that will be a f of 6, and that will give me that answer, which will be 3.250666 or 3.25 metres. Okay, so that's A done. B, find the average height of the water between 6 a.m. and 6 p.m. So now we are average value. So that will be from 6 to 18, 1 over 18 minus 6 of, is it called H? H of H of T dt, which will equal 1 on 12. And we're doing the integral of f of x from 6 to 18. Which gives you that number, which is 2.97933, rounded to two decimal places, 2.98 metres. Okay. That requires a height of more than 1.4 metres to safely launch the ramp between 6 a.m. and 6 p.m. this Monday. So between 6 and 18, find the total time when it is safe to launch the boat. Okay, so let's have a little look. And we want to go from 6 to 18. And okay, and let's have a little look at f of x. Let's go the height a little bit higher than that. Let's go to say 6. And I want to be higher than 1.4. Okay, so it's higher always here, it's higher at the start. Let's have a little look and see what's going on in here. Ooh, we're below, then above. Okay, so let's find these intersection points. So we are above from term 0 to times 7.8035. Then we are below, and we're above again from 7.94931 through till 8.276173, and then we are above again from 10.66388 through to 18. Okay, so we're starting at 6. That's going to go from 6 to there. So that will be 1.8035 from 7.9 to 8.27. 8.2, so that's plus 0.326863. Last from there to there will be between 18 and that is plus 7.33612. And that is 1.8. And that gives you an answer of 9.466483. Two decimal places, 9.47 hours. Okay, that's question number 2. Find the absolute maximum height of the water after 6 a.m. and the time when it occurs. So, if I go back to Zoom previous, there's so I'm looking for the absolute maximum between 6 and, was it between there and there? So analysis, GSOL, F max, and I'll accept that. There's all places. So there is the absolute maximum, a Y value of height equals 5.196165 at T equals 15.5035. So the maximum height decimal places, 5.20 meters at 15, and we rounded to the nearest minute. So that's 15 hours 30 minutes. So at 3:30 p.m. should be the time. Show that H or 25 is the same. Okay, so you got here, do we have a H of X and Y? Yeah. Copy, paste. Okay. So H of 25k is going to equal 2 sine of 4 times 25k times pi over 25 plus 1/5 sine of 3 times 25k pi plus 3. There'll be 2 times the sine of 25's cancel, 4k pi plus 1/5 sine of 75k pi plus 3. This will be an even number of pi. The sine of 4k pi is equal to 0, so that's going to equal 0 plus 1/5. The sine of 75k pi is going to equal 0, equals 3. Find the period of the function. Okay, so the period of each of them separately. So if I'm looking for the sine of 4 pi x on 25, the period of this will be 2 pi on 4 pi on 25, which is 25 on 2. And the sine of 3 pi x is going to be, period is going to be 2 pi on 3 pi. It's going to be 2/3. So we need a common multiple of both. So 25 on 2, or 25, or 75 on 2, or 50, or 125 on 2. So check which of these. So the period of the function, which is all of this, will be what both 2/3 can divide into and what 25 on 2 can divide into. So I've got all the multiples of 25 on 2. So 25 divided by 2 divided by 2 divided by 3 doesn't go wholly. So let's try 50 on 2. That doesn't go wholly. Let's try 75 on 2. That doesn't go wholly. Let's try 100 on 2. Oops, 75. So 50 is the period. And that will be in hours.